Hello everybody. In this video lecture, we are going to discuss about the Atmega 328P, their features, architecture, and AVR core CPU also, and also their applications. Let's start with the features one. Uh, the features of Atmega 328P are advanced in RSC architecture, special controller features, and there are also peripheral features and so on. From the features point of view, these features are differs from hardware to hardware. From data sheet of Atmega 328P, the features are like this. There is a advanced RISC architecture, which includes 131 powerful instructions and most signal clock cycle execution. 32 into 8 general purpose working registers are there. Fully static operation performed in this hardware up to 20 MIPS through output at 20 megahertz. One chip 2 cycle multiplier is this. There is a second one is peripheral features. In this, there are two 8-bit timer counters with a separate per scaler and compare modes are there. Second one is a 16-bit timer counter with a spread prescaler compare mode and capture, which is an additional feature of that. And there is a mode real-time counter with spread oscillators. The second one is 6 PWM channels are there, 8 channels of 10-bit ADC in TQFC and QFN MLF packages. This is the temperature for use for temperature measurement. And second, next is the 16 channel. Previously that is a 8 channel, and this is a 6 channel 10-bit ADC in PDIP packages, which is also used for a temperature measurement purpose. That bits, not that channels. Two masters and save SPI serial peripherals interface are there. This is used for monitoring the data from the remote location to anywhere of in the world, or from your remote location to the local location, or local location to remote locations. So next one is the one programmable serial USRT. Also there is a 1 byte oriented 2-wire serial interface, which is of Philips I2C compatible. Next is programmable watchdogs timers with separate on-chip oscillators for delaying for giving a delay to a computer, or for a pause for a particular operation. The timers will be used over here, and it is embedded in a program. One on chip analog comparator is there. Interrupt and wake up on pin change is there. Next features is special controller features, in which the power onset and programmable brownout detections are there. Also there is a internal calibration oscillators and external and internal interrupt source, like a 6 sleep mode, ideally ADC noise reduction, power slave, power down, standby, and extended standby is there. These are all the features of Atmega 328P. Next is a block diagram of Atmega 328P. In this block diagram, we can see there is a AVR CPU, that is AVR core CPU is there. There is a flash, EPROM and EPRAM memory is there. There is an internal reference and USRT ports and TWI ports are there. There is a ADC port also there, and this is the IO data bus, and this is the data bus for the changing the data from one side to the another side, or one component to element to the another element. There is a IO ports in IO data bus connected, and GIPRS is connected. There is a TC and SPI, and also an AC is there. These are the VCC, that is positive reset pin for power supervision, probe out and reset. And there is a ground pin is also there, which is which we have to be connected. And there is a clock generation or debug wires are there. This is all the block diagram components of Atmega 328P. Next one is the block diagram of AVR architecture. From this AVR architecture, we will go through the architecture of AVR core CPU. There is a file registers and program counters. There is a flash memory and instruction registers, instruction decode data memory. There is a stack pointer and stack register, which is will be led to ALU. Now let's see the function of these blocks. As we discussed in AVR architecture, there are a few components like a register, instruction set, IO ports, memory, flash, and RAM and ROM, and CPU. Uh, we, Now we will see the functions of these components. In order to maximize performance and parallelism, the AVR use a hardware architecture with separate memories and buses for program and data. Instructions in the program memory are executed with a single level piping. Uh, then while one instruction is being executed, the next instruction is prefaced from the program memory. This concept enables instruction to be executed in every clock cycle. The fast access register file contains 32 into 8-bit general purpose working registers with a single clock cycle access time. The area ALU supports the arithmetic and logical operations between the registers or between a constant and a registers. The ALU operations are divided into three categories like arithmetical, logical, and functions. The program counter PC, that is PC, commonly called the instruction pointer, is a 14-bit side, thus addressing the 1 GK program's memory location. It contains the address pointer value of current instruction. Each cycle, the program counter is updated to point to meet a next instruction. An instruction register is the part of CPU control unit that holds the instruction currently being executed or decoded. The instructions decoder is the circuit that decodes an opcode, and the status register contains information about the result of most recent executed arithmetic instruction. This instruction can be used for altering a program flow in order to perform a conditional operation. The stack is mainly used for starting temporary data and for stacking local variables and for starting a returns address after interrupts and subroutines. The stack is effectively allocated in the general data like RAM, SRAM, and consequently the stack size is only limited by the total SRAM size and the uses of SRAM. The stack pointer register always point to the top at the stack. The program memory is in a system reprogrammable flash memory. Program flash memory space 32K is divided into two sections. The boot program sections and applications program sections. Both sections have dedicated log bit for write and read and write protections. In Atmega 328P, SRAM memory is organized as 32 general purpose working registers, 64 IO registers, and 1 GB extended IOS registers, and 2 KB of internal data SRAM is there. Um, Among this, with the Atmega contains 1 KB of data EPROM memory also. This is the functions of each component of Atmega 328P architecture. These are the sum of applications of Atmega 328P, which is used in, normally this hardware is used in the industrial control system, SMPS and power regulator system, digital data processing, analog signal measuring and manipulations, embedded systems like coffee machines and vending machines, and also in a motor control system and display units, and also in a peripheral interface system. I hope you will get the all information regarding Atmega 328P, like its feature, application, AVR core architecture and block diagram of the same. Thank you.